Hello and welcome to another one of D's ADD videos. Today we're going to look at an intermediate example of the second derivative test for extrema. Again, quick review. Take the first derivative, set it equal to 0, get your critical points. Take the second derivative, plug those critical points into the second derivative. If it's greater than 0, it's a relative min. If it's less than 0, it's a relative max. If it's equal to 0, it doesn't tell you anything. So let's see an example. Here we have a function, a rational function, and we're asked to determine extrema using the second derivative test. So the first thing you should recognize is that we have a quotient here. So in order to do the derivative, you have to recognize that it's a quotient rule. So hopefully you remember your quotient rule and you remember it however you want to. I remember it using this little acronym, low d high minus high d low over low squared. You take the derivative of anything after the d. So this is the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. So doing that, we would get this right here. So there's the bottom derivative of the top minus the top times the derivative of the bottom. Now the next step is to clean house a little bit. So if you distribute that 4 through and the 4x through, you should get this. And then after that, you can combine your like terms in the numerator to get this numerator over that denominator. So that's a denominator. That's your first derivative. Now you got to set the numerator equal to 0 to find your critical points. So when you do that, you factor out the negative 4, and there are no factors that add up to 8 and multiply to negative 10. The only factors of negative 10 are either negative 5 and 2, or negative 2 and 5, or 10 and negative 1. So then you ask yourself, can I use a quadratic formula? Because b squared minus 4ac is positive, yes you can. At that point, what is my a, b, and c? My a is going to be my 2, my b is going to be my 8, and my c is my negative 5. So we have a negative 8 plus or minus 8 squared minus 4 times 2 times negative 5, just plugging into the formula over 2. Simplify a little bit. You can do this on your own. Okay, just verify all those steps are correct. I am human, I do make mistakes. So if you were to plug in your calculator, you get these two critical points of negative 0.5495 or negative 4.5495. So now what we got to do is take the second derivative to plug those critical points into that. So again, the quotient rule, it's the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. So you can factor out a 4 common of both of these, actually a negative 4, and one of the two exit minus 5s. So if you do that, this is what you're left with here. And just take what you had originally, divide by what you're factoring out, and you should get this here. And at that point you can cancel one of these with one of those, distribute, FOIL this out, you get that here. Combine your like terms, and you should end up with this equation here. Then the next step is to plug in. This is the equation you should end up with when you combine your like terms. and then simplify to that when you distribute the -4 through. Plug in your two critical points. You get that. So greater than 0 is a relative min, less than 0 is a relative max. Again, you should find the corresponding y value by plugging in those x values into here. I'm not concerned with that part. You should be able to do that. It's just a calculator exercise. My point in doing this video is for you to practice the quotient rule and to also be able to do the relative extrema using the second derivative. So hopefully I've cleared up any doubts you might have. Practice, practice, practice. Thank you and have a nice day.